Welcome back to Alpha Beta Tutorials. If you are preparing for WASSCE Physics, you are in the right place. In this video, we are solving question 8 of the 2022 WASSCE Physics Theory Paper, which focuses on motion, forces, and energy. I've already covered questions 1 to 7 in a separate video. You can find a link to that in the description below. So be sure to check it out if you haven't already. The remaining questions will also be covered in upcoming videos, so don't forget to subscribe and stay tuned. Let's dive right into question 8. Question 8AI. State two differences between a contact force and a field force. Now, a contact force is a force that needs physical touch between objects. Example is frictional force, which is a force that opposes the relative motion between two surfaces in contact. But a field force acts from a distance without touching. Examples are gravitational force, magnetic force, etc. So let's look at two differences between contact force and field force. Contact force involves two or more surfaces in touch with each other, but a field force operates in a region. That is one difference. Contact force is caused by mechanical interaction, whilst a field force is caused by a field, like a magnetic field. Now, the II part define the term gravitational field intensity. This is a straightforward question. Gravitational field intensity is the force per unit mass on an object on the Earth's surface. Now, the B part of the question. A body is given an initial velocity of 40 meters per second at a point P. So let's say we have a point P here, and the body is given an initial velocity of 40 meters per second. Now the body decelerates uniformly and attains a velocity of 20 meters per second at a point X. So the body reduces its velocity to 20 meters per second at a point X. The body is finally brought to rest at a point M. So the body reduces its velocity to 0 meters per second at a point M. Now, if the time taken by the body through the whole journey is 20 seconds, and the distance covered from P to X is 200 meters, so the distance from P to X is 200 meters. We are to calculate I part of the question, deceleration of the body. Now, for the deceleration of the body, let's consider the movement from P to X. And the initial velocity is 40 meters per second. The final velocity here is 20 meters per second. And the distance is 200 meters. And we want the acceleration. We want the deceleration. Since the deceleration is the negative of acceleration, we are going to find the acceleration here. And given the initial velocity, final velocity, and the distance, Newton's third equation of motion can help us find the deceleration. And that is v squared is equal to u squared plus 2as, where v is the final velocity U is the initial velocity, A is the acceleration, and S is the distance. And the final velocity here we have 20. So we square it. Initial velocity here is 40 meters per second. We square it plus 2 times the deceleration we are finding times the distance between P and X, which is 200 meters. And now 20 squared is 400, and 40 squared is 1600, plus 2 times 200 will give us 400 times the deceleration. And now let 1600 cross the equal to sign to subtract from 400. So we have 400 minus 1600 is equal to 400A. And 400 minus 1600 is negative 1200, which is equal to 400A. And when we divide through by 400, we'll have negative 1200 divided by 400 is equal to 400A divided by 400. And so we have A to be equal to negative 3. So the deceleration is negative 3 meters per second squared. II. Calculate the distance between X and M. So between X and M, the initial velocity here is going to be 20 meters per second, and the final velocity is going to be 0 meters per second. And remember, the body decelerates uniformly. So the deceleration we had between P and X, which is negative 3 meters per second square, is going to be the same between X and M. And knowing the initial velocity, final velocity, and deceleration, and we are to calculate distance between X and M, Newton's third equation of motion is going to be helpful. So we have final velocity squared is equal to initial velocity u squared plus 2 times the acceleration times the distance. So the final velocity is 0, so we have 0 squared. Initial velocity 20 squared plus 2 times the deceleration, which is negative 3 meters per second squared, times the distance we are looking for. 0 squared is 0, and 20 squared is 400. 2 times negative 3 is negative 6 times the distance. And let's bring negative 6 to the left hand side of the equation to be positive 6 times the distance is equal to 400. Let's divide both sides by 6. 6s over 6 is equal to 400 over 6. And so the distance s is equal to 400 divided by 6 is 66.7 meters to 1 decimal place. That is the II part of the question. The III part of question 8b, we are to calculate the time taken by the body to move from X to M. And the movement from x to m, we know the initial velocity is 20 meters per second. We know the final velocity to be 0 meters per second. And we know the deceleration to be -3 meters per second square. So this information is enough to calculate the time between x and m. So we can use Newton's first equation of motion. That is, the final velocity is equal to the initial velocity plus acceleration times time. And the final velocity is 0 meters per second. Initial velocity is 20 meters per second. The deceleration is -3 times the time. So we have 0 is equal to 20 minus 3t. And let's bring t to this side of the equation. We will have 0 plus 3t to be equal to 20. 0 plus 3t is 3t. And we divide through by 3. So 3t divided by 3 is equal to 20 on 3. When we cancel 3, we have time to be 20 divided by 3 is 6.7 seconds to 1 decimal place. And that is the time taken by the body to move from x to m. For C part of question 8, a box of mass 210 kilograms. So let's assume we have a box of mass 210 kilograms. Is pulled from rest. It means the initial velocity u is 0 meters per second with a string of tension 1300 Newton inclined at 35 degrees to the horizontal. So the box is being pulled with a force of 1300 Newton, but the force is inclined to an angle of 35 degrees to the horizontal. If the box moved with a speed of 10 meters per second, it means the final velocity here is 10 meters per second. And the frictional force between the box and the surface is 100 Newton. We are to calculate the distance covered. And friction always acts in opposite direction to the motion of a body. So the friction, if the body moves this way, the friction will act in this direction. And first of all, let's resolve this force to the horizontal. To resolve the force to the horizontal, we have to multiply 1300 by cos of the angle of inclination. That is 1300 cos 35 degrees. That will be the resolution of the force to the horizontal. And now, if the force acts in this direction and the friction also acts in this direction, then the net force is going to be the difference between the force and the friction. That will be the 1300 cos 35 degrees minus the friction, which is 100. That will be the net force. And you know, force is equal to mass times acceleration. So we have an equation here. And 1300 cos 35 degrees is 1064.9. Then we have minus 100 is equal to the mass, which is 210 in the question, times the acceleration. And now 1064.9 minus 100 is 964.9 equal to 210 times the acceleration. And so we divide through by 210 to get the acceleration. And so acceleration here will be 964.9 divided by 210. And so the acceleration here is 4.6 meters per second squared. We have to calculate the distance covered. And the body is pulled from rest. So the initial velocity is 0 and it moved with a speed of 10 meters per second. So the final velocity is 10 meters per second. We have u to be 0 meter per second, v to be 10 meters per second, and we are looking for the distance. We have the acceleration here. So Newton's third equation of motion will be helpful. That is, final velocity square is equal to initial velocity square plus 2 times acceleration times the distance. So here we have 10 squared is equal to 0 squared plus 2 times 4.6 times the distance. 10 squared is 100. 0 squared is still 0. So we have 2.2 times 4.6, which gives us 9.2 times the distance. Then we divide both sides by 9.2. So 100 divided by 9.2, 9.2 times distance over 9.2. And so the distance here is 10.9 meters.